Hi, grade 11. Welcome to lecture number 5. This is about hypothesis testing on two population. In statistics, more often than not, we're interested with comparing two groups. See, for example, who has a better reaction time? Is it the male or the female? Or which review program is effective? So you're going to compare the mean score of those students who went to a particular review program versus the mean score of those students who went to another review program. So you're going to compare which program is more effective. Also, if you want to determine whether a diet program is effective, then you can measure um, the group of individuals who went through the diet program, their initial weight, and then compare it to their final weight. Or you can determine whether whether a review program or whether a teaching method or strategy is effective by comparing the pre-test scores of those students versus their post-test scores. Okay, so if you want to answer those questions, then this technique will actually help us. At the end of the lesson, you are expected to, number one, distinguish the two types of samples. And we're going to perform hypothesis testing on two population means using different samples. Actually, for hypothesis testing on two population, you can compare proportions, you can compare variances. But for this lecture, we just focus on different population means lang. Okay, so as a sort of review, we're already done with this one on lecture 3, and then one population in lecture 4, and now we will now do two population. For two population, we'll do the technique for related samples and for independent samples. Actually, for independent samples, we'll still distinguish whether we're going to assume equal variances or unequal variances. So basically, meron pa tong parang ano pa dyan, branches, dalawa pa. Here are the general steps in hypothesis testing, and we will still be following these 7 steps. We'll first state a null and alternative hypothesis both in words and in symbols. We're going to determine the appropriate test procedure and test statistic, level of significance. We're going to write our decision rule. We're going to calculate the values of our test statistic, decide whether to reject or not to reject our null hypothesis, and make a proper conclusion. Recall that in the hypothesis testing in one population mean, our parameter of interest is the population mean, mu. But for two population means, our parameter of interest will be mu sub d, which is the mean difference of the population. In symbols, the difference between the means of population 1 and population 2, that's mu d, that's equivalent to mu sub 1 minus mu sub 2. Okay, now let's distinguish the difference between related samples and independent samples. For related samples, it's also known as paired samples. Samples that came from two measurements of the same unit of interest or two different units, but almost similar to each other, or paired with one another, or they have a natural pairing. Say for example, yung unit mo, you're going to use twins. So for example, you have 10 twins, then your first twin that will be subjected to one treatment, and then the other twin will be subjected to other treatment. Then you're going to compare whether there's a difference between the effects of those treatments. So we use related samples, or you use husband and wife, or say for example, you use one set of students and then you compare their pre-test and post-test. So dalawa pa rin yung kino-compare mo, pre-test and post-test, but it came from one group of people only. So that's related samples. On the other hand, independent samples, if samples are generated from two different populations. So for example, you want to compare the performance of section A and section B, magkaibang tao yon. Or you want to compare the performance of a diet program using one set of or one group of people on a particular center, and then another group of people on another center. If you want to compare the fertilizer, the effect of a fertilizer, so you say for example you have fertilizer A and fertilizer B, then you have one set of plants over here and then another set of plants over here. Okay. Let's have this. A study was conducted to investigate the effectiveness of pain-reducing medication. Results for randomly selected subjects are shown. Isang grupo lang yung pinili. A lower score indicates less pain. The before value is matched to the after value. And the difference are calculated. The differences have a normal distribution. Are the sensory measurements on the average lower than the medication? That's what we're going to answer later. So in this case, this is related samples because we just randomly selected 1, 2, 3, 4, 5, 6, 7, 8 individuals, and then we measure the before sensory measurement, okay, and then after sensory measurement. Yeah. So in this case, we're going to compare the before and the after. They are related, they are matched pairs. For the independent samples, let's have this example. A professor at a large community college wanted to determine whether there's a difference in the means of final scores between students who took his statistics course online and those who took his face-to-face statistics class. So magkaibang grupo na to, no? Yung mga nag-take nung stat class online and then those students who took the statistics class face-to-face. And then the professor wanted to determine if there's a difference between the performance, the mean performance or mean final exam scores of the two sets of students. So in that case, since magkaibang grupo to, so that's independent samples. Okay, so here is again a side-by-side comparison of a related samples example and an independent samples. Here are the assumptions that we need to satisfy before we can use this technique. For related and independent samples, kailangan the variable should be at least of interval scale, so interval or ratio. Samples are randomly selected using simple random sampling. For related samples, ang bawat unit natin ay pair na. So they should be randomly selected. And for independent samples, since we're comparing two populations, samples from each population should be randomly selected. The difference of the two data came from a normal distribution. Since our parameter of interest here is the difference between the means, then they should be normally distributed. And for this course, we will just assume that all of these things will be satisfied. And when you go to research 2, there's actually a way for you to determine if the distribution is normally distributed. And if it's not satisfied, then you have to go for a non-parametric test. And here are the test statistics. You will notice for related samples, we just have one formula for the computed value of t. But for independent samples, we still have to categorize whether we're going to assume equal population variance or unequal population variance. Now, how do we determine? Actually, there is a test. There are tests to know whether we're going to assume equal variance or unequal variance. In SPSS, we have this Levene's test, or you can use an F test. But don't worry about this. You will do this in research too. But for our case, I will tell you whether you're going to use equal variance or unequal variance. Basically, they have slightly different formula. Kasi dito, you have two different variances for the two. This should be n sub 2. N sub 2. N sub 2. Okay, but for this case, yung parang yung ano mo, yung S sub 1 mo, naging ano siya, naging isa lang. So in other books, they call it pooled variance. Okay, in other books, you will also see that they call this pooled t-test, and the other one is unpooled t-test. Okay, but in most cases, we'll just be going to the pooled t-test. I'll explain why. And here are the different test procedures. You're going to look at your alternative hypotheses. If it's unequal, if it's greater than, or if it's less than, then here are the test procedure. And also, you want to take note whether your n is less than 25 or more than 25. In this case, your n here, if just in case you're going to do independent samples now, your n here is n sub 1 plus n sub 2. So yung total nila. Okay. And for the degrees of freedom, just in case you're going to use the t table, for related samples, it's just n minus 1. For independent samples, but assuming equal population variance, it's n sub 1 plus n sub 2 minus 2. However, for unequal variance, you have this formula for the degrees of freedom. So basically, this is the reason why, in most cases, we'll just be doing the equal variance, assuming equal variance. And actually, there's a way to determine a rough rule of thumb if we're going to assume equal population variance, which I will tell you later kapag nag-example na tayo. Let's have the first example for paired samples t-test. Study was conducted to investigate the effectiveness of pain-reducing medication. Results for randomly selected subjects are shown in the table. A lower score indicates less pain. So the before value is matched to the after value, and the difference is calculated. Are the sensory measurements on the average lower after the medication? Mas mababa ba daw yung measurements after the medication? So in this case, let's use mu. Let's define mu as the mean score, yung sensory measurement. Mean score before medication. And then mu sub 2 naman, it's the mean score after medication. Now, if the medication is effective, then kailangan bumaba. So, ibig sabihin, we want the before to be greater than the after. So, habang dumadaan yung tricycle, sipin nyo. Tama ba? We want the before to be greater than the after. Okay. So, our null hypothesis. So, we will just be assuming na equal muna sila. Kasi, no difference, hindi effective, hindi nagpa-lower hindi na-lower ng medication yung pain. So, that's, the average sensory measurement is the same after the medication. Ibig sabihin, mu sub 1 is equal to mu sub 2. On the other hand, for the alternative, so we'll have this. Kung napa-lower nung medication yung pain, then the before measurement should be greater than the after measurement. So we have this one. Okay. Now, we're now ready to determine the appropriate test procedure. Let's have this table. Since our alternative hypothesis is greater than, so we'll be doing this one. Our n is just 8. So dito lang tayo sa n is less than 25. So our test will be one-tailed related samples t-test. Our alpha is 0.05 because it was stated here 5%. And then our decision rule will be at the 5% level of significance. We're going to reject the null hypothesis if the computed value of t is greater than the tabular value. Otherwise, we fail to reject IHO. Okay, we change location. We're now ready to compute for the test statistic or the computed value of t. And I prepared this table for us. I put here the before and the after scores. And then the d is the difference between before and after. So that's before minus after. So that's 6.6 minus 6.8 equals negative 0.2. So basically, you just have to get the difference of everyone. You can use your calculator for that, and you'll get the following values. And then you get the sum of everyone. The sum is 25. And then we're now ready to compute for d bar, or the mean difference. So in this case, get the summation of d divided by n. We'll get 25 over 8, which is 3.125. Okay, now, the next thing we need to do is to get the standard deviation, which is this. So, ibig sabihin, we still need to get d minus d bar. So, pinalawa ko, nilagyan ko ng dalawa pang columns yung ating table. Column for d minus d bar and then d minus d bar squared. So, ang nangyari dito, bawat d's, ma-minusan natin ng 3.125. So, it's negative 0.2 minus 3.125. That's negative 3.325. And then you do it for everyone. Then after getting the difference, you have to square it. So, we'll get this very large number. Small number ito, pero madaming decimal places. Then you'll get everything, square nyo, and then finally get the sum sa pinakadulo. So, I got 59.335. So, yung isa-substitute natin dito. And then get square root of 59.335 divided by 8 minus 1, and you'll get 2.9114. So, dalawa lang yung kailangan natin, d bar at saka standard deviation, to get the computed value of t. So, let's substitute. D bar is 3.125 minus 0. So, d sub 0 is here. This is the hypothesized mean difference. Saan galing yun? Yung hypothesized mean difference. Basically, galing yun. You can look at your null hypothesis. Remember, your mu sub 1 is equal to mu sub 2. That's your null hypothesis. So, kapag tinranspose natin siya dito sa kabila, we'll get mu sub 1 minus mu sub 2 equals 0. So, yun yun. Hypothesized mean difference. Okay? And then, SD is 2.9114. So, this yun. And then square root of 8. So, the final answer is 3.0359. Okay. By the way, just in case, sorry, hindi ka malaglag. Pwede nyo gamitin yung calculator nyo to compute for the mean and the standard deviation. Itong 2.9114. So, ang gawin lang natin, you set your calculator into stat mode and then encode all the differences. So, ito, encode nyo 0.2, 4.1, 1.6, encode nyo lang siya. And then, go to stat mode, choose 1s-var, and then, sa stat mode nyo, shift 2 kung kasyo yung ginagamit nyo or just get the statistics na kailangan natin. So, in this case, we will be selecting 2 for the d-bar. So, we'll get 3.125, yun, 3.125, at matatakloban ng video ko yung SD. But anyway, you just select 4, SX, that's the sample standard deviation. Yeah, takloban nga. But anyway, it's 2.9114. Okay, just in case you don't want to work on the, you don't want to work with too many decimal places, then you can just use your calculator. Okay. So we're now ready to get the tabular value. Yeah, we need to get T alpha and then the degrees of freedom. Remember, degrees of freedom for this is just n minus 1. So we have 0.05, 7. So then let's get your critical, the tabular values or critical T values. We are going to go for the one tail at 0.05 degrees of freedom 7. So our tabular value is 1.895. Okay. So we're now ready to make a decision. We're going to reject the null hypothesis if the computed value of T is greater than the tabular value, and obviously 3.0359 is greater than 1.860, which means we're going to reject the null hypothesis. So our final conclusion, therefore on the average, the sensory measurements are lower after the medication.